Now, if you have ever been to a website, and I'm assuming yes, then you will have experienced typing in the address of that website into your browser, and then the website displays on your screen. And what's actually happening is your computer is connecting to the server of that website, it's downloading the web page, which is then being displayed for you to see. Now, if you were to go to a different website, you type in that address, that also connects. And the fact that you're connecting to two physically different servers, possibly even in different countries, you don't notice at all. The reason that can work is because of networking and the internet. When you have an internet connection, your computer at home or in the office can connect to whichever server you point your web browser at. And because of that, you don't need to connect to one Wi-Fi network to get onto Google, a different Wi-Fi network to get onto Amazon. You just type in the address. Now, when we're sending audio around a data network, then actually we're taking advantage of exactly the same principle. We're able to have a receiver which is able to pull its audio from this source, or pull its audio from this source, or from over here. And as long as those sources are in that local network, you don't need to do any patching. You don't need to change any cabling. All you're doing is changing the routing of the audio. Now, in order to make that possible with StageLink, we have all of these StageLink boxes. They're all linked into the network, or networks, which I'll come on to in a moment. Now, this advantage of not having any physical repatching means that your cabling can be simplified. You have just one or two or three cables connecting the network to your StageLink box, and then that cable will carry everything it needs. So whichever source you're patching to an output, whichever output you're sending a source to, you just have that one infrastructure. And networks are effectively infinitely expandable, so you can add in as many channels as you like. Just think of a traditional audio router or video router where you actually have an unlimited number of channels. Now, I was talking just a moment ago about using 2 or even 3 cables to get onto the network, and part of that has to do with redundancy. Now, in a broadcast environment or in a theater environment, in any mission critical system, actually, you're going to want to have a lot of redundancy built into your system. So if, for example, one side of the network falls out, all of the connectivity should remain untouched on the other side of the network. Now, on the StageLink boxes, we do that with these 2 ports. We can have 2 simultaneous streams using the SMPTE 2022-7 protocol. We can have the 2 connections to the 2 networks coming over these 2 Ethercon connectors. So that means if this network were to drop out completely, the network gets flooded, or power fails to the entire network infrastructure, or the core switch for that network goes down, or someone disconnects the cable, cuts through it, whatever happens, the data can continue to go over the other network connection. And actually the switching between the networks happens on a per packet basis. So if you are experienced in doing audio productions in a professional environment, if ever you've used a radio mic, I'm sure you have never used a radio mic that did not offer true diversity. And if you look at a true diversity radio mic receiver, you'll see that you will have an A signal and a B signal, which are constantly on the display of the receiver. And what the receiver is tuning into is whichever one of A or B is stronger. And it doesn't matter if they change 10 times a second or once every 10 minutes, they'll just stay locked on to the strongest signal. And when we use 2022-7 with the 2 network connections, that means that, again, we're locking on to the strongest signal. So that could mean the first one to arrive there. So if one's delayed, then it doesn't get used. But at the same time, if a packet is lost on the network, then as long as it's present on the other network connection, it's there for the receiver, and therefore you have a stable connection. Now, we also supply power to the devices via the media connections. So we supply PoE Plus down each of these connections. You'll notice that with the exception of the GPI box, which I have here, that none of them actually have an external power supply. So if we're connecting any of the audio boxes, we are supplying PoE Plus down the Ethernet connections, and that's the only power supply we have available. But because there's 2 of them, again, we have redundant power supplies. If power fails from one network, it then is available from the other network and it's not going to go down. Now, in some installations, it's very important to have out-of-band management. Now, what this means is that basically we separate all of the media, all of the audio, from the instructions that are being sent to the box to tell it how to react. So if, for example, we want to identify a box and we click on the link in the web interface to make all the LEDs flash in order to identify it, that kind of information counts as management information. So it's not going to be going over the media network if we have out-of-band management. Now, the reason that we have 3 network ports on the back of each StageLink device is to offer this out-of-band management. So we have Media 1, Media 2, and the management port. Now, the management port would then be connected to a non-media network and would then allow complete separation of the media and controls so that if too much media was in the network and maybe IGMP failed for whatever reason, you can still access the device. You can still management. If it's one device that's causing that network flooding, you can shut that one down. So it allows you a route into the devices even if the network that's being used for media gets oversaturated. Now, what we can also do with the StageLink boxes is we can actually use each box as a network repeater. So that means with up to 100 meters of Ethernet cable for each hop, we can then start linking them together, daisy chaining them. We can also close off that ring to connect both ends into the switch on the condition that you have rapid spanning tree protocol up and running to ensure you don't have any network loops. But if that is implemented in your switch, then you can connect both sides of it and that will give you a load of redundancy. It will mean that if one of the boxes drops offline for whatever reason, or one of the cables gets cut, everything stays connected all the time. And so you're guaranteed to have that continuous operation unless multiple things start going wrong at the same time. Now, with the network access, we also offer NMOS control. The StageLink devices are built to work in a 2110 network, which means that for ease of management, we do offer NMOS control if we're running them in that kind of mode. With the NMOS control, we can allow the NMOS registry and the NMOS controller to access the StageLink devices either through the media ports or through the management port. We can separate that out as necessary depending on how your situation is set up. Just one last word about running over a network is we need to also remember that because we're in a 2110 network, we do need to be providing PTP to the devices. Now, I'm not going to go into the details of PTP in this video, but it's basically a really precise synchronization protocol that will allow all the devices to be genlocked together, to be synced together, just like if you were connecting a MADI source to a MADI destination, you need to make sure they're genlocked or using a sample rate converter to avoid any clicks and pops in the MADI connection. With PTP, we need that synchronization to make sure that the audio is synchronized, that there are no dropouts, that there are no artifacts in the audio or spurious signals. So the PTP is supported in the boxes. We can send that in on the Media 1 and the Media 2. And this redundancy means that if something happens to Media 1, the audio can go through Media 2. If something happens to Media 2, everything can go through Media 1.